Welcome to Educatio Publishing. Let's kick things off with some physics practice tests. Get ready to dive into the questions and discover the answers along the way. Let's start learning together. Physics. 25 items suggested time, 50 minutes. Question 1. Which of the following is true about compacting a junked car? A. Its mass increases. B. Its mass decreases. C. Its density increases. D. It loses some of its density. Answer. C. Explanation. Since density equals mass/volume, it should be obvious that the decrease in volume as a car is crushed should lead to an increase in density. Nothing changes the car's mass. Question 2. An automobile goes 3 miles north, 6 miles south, 2 miles east, 2 miles west, and finally 3 miles north. Which of the following is correct? A. The car's displacement is 16 miles, and the distance driven is 0 miles. B. The displacement of the car is 16 miles, and the distance traveled is 16 miles. C. The displacement of the car is 0 miles, and the distance traveled is 0 miles. D. The displacement of the car is 0 miles, and the distance traveled is 16 miles. Answer. D. Explanation. If a car travels 3 miles north, 6 miles south, 2 miles east, 2 miles west, and then 3 miles north, it has traveled a total distance of 16 miles. However, because of the directions it has traveled, it has ended up in the place where it started, giving it a displacement of 0. Question 3. Why doesn't a raindrop speed up as it gets closer to the ground? A. Gravity pulls it down at a constant rate. B. Air resistance counteracts the gravitational force. C. Its mass decreases, decreasing its speed. D. Objects in motion decelerate over distance. Answer. B. Explanation. Gravity in fact causes acceleration, making choice A incorrect, unless air resistance counteracts that acceleration, which it may easily do for an object as small and lightweight as a raindrop. Raindrops may lose mass, choice C, but that would not decrease their acceleration. Choice D violates Newton's first law. Question 4. An object moves 100 m in 10 seconds. What is the velocity of the object over this time? A. 10 meters per second. B. 90 meters per second. C. 110 meters per second. D. 1000 meters per second. Answer. A. Explanation. Velocity is the change in distance over time. 100 m/10s is the same as 10 meters per second. Question 5. Which of these objects has the greatest momentum? A. A 1,250 kilograms car moving at 5 meters per second. B. An 80 kilograms person running at 4 meters per second. C. A 10 kilograms piece of meteorite moving at 600 meters per second. D. A 0.5 kg rock moving at 40 meters per second. Answer. A. Explanation. Momentum is calculated by multiplying mass by velocity, P equals mv. Although the meteorite seems intimidating, it is the car that has the greatest momentum, at 6,250 kgm/s. Question 6. Sublimation occurs when matter transitions from solid to gas or gas to solid without going through a liquid phase. Outside of the laboratory, which solid best exemplifies this? A. Iron. B. Silver. C. Salt crystal. D. Dry ice. Answer. D. Explanation: dry ice is composed of frozen carbon dioxide. As it breaks down, it transforms directly into gas without passing through a liquid phase. Sublimation of metals is possible, but not outside of the laboratory. Question 7. A ball is at the top of a hill. Which factor, or factors, is responsible for its potential energy? A. Its position and its mass. B. Its acceleration and its position. C. Its mass. D. Its circular shape. Answer: A. Explanation: a ball on a hill would have potential, or stored, energy because of its location on the top of a hill and because of its mass. Recall that gravitational potential energy is the product of an object's mass, position, and acceleration due to gravity. Question 8. A 60-watt light bulb is powered by a 110-volt power supply. What current is being drawn? A. 0.55 amperes. B. 1.83 amperes. C. 50 amperes. D. 6,600 amperes. Answer: A. Explanation: the equation P equals IV, power equals current times voltage, is the one to use. Dividing the power by the voltage gives you I equals P/V, and 60 watts/110 volts equals approximately 0.55 amperes. Question 9. A wave moves through its medium at 20 meters per second with a wavelength of 4 meters. What is the frequency of the wave? A. 5-second inverse. B. 16-second inverse. C. 24-second inverse. D. 80-second inverse. Answer: A. Explanation: according to the equation V equals F into L, frequency is equal to the velocity of the wave divided by the wavelength. Dividing 20 meters per second by 4 meters gives you a 5-second inverse. Question 10. An electromagnet is holding a 1,500 kilograms car at a height of 25 m above the ground. The magnet then experiences a power outage, and the car falls to the ground. Which statement below is untrue? A. The car had a potential energy of 367.5 kJ. B. 367.5 kJ of potential energy is converted to kinetic energy. C. The car retains a potential energy of 367.5 kJ when it hits the ground. D. The car's potential energy converts to kinetic energy and then to sound energy. Answer: C. Explanation: when the car is attached to the electromagnet, its potential energy, P, is 367.5 kJ because P equals mgh, or 1,500 kilograms multiplied by 9.8 meter per second square, multiplied by 25 meter. As the car falls, all 367.5 kJ of P are converted to kinetic energy. On hitting the ground and making a sound, the car will no longer possess any PE. Question 11. Why does potential energy increase as particles approach each other? A. Attractive forces intensify. B. Attractive forces decrease. C. Repulsive forces increase. D. Repulsive forces decrease. Answer: C. Explanation: unlike charges attract each other, like charges repel each other. As two like charges near each other, work is required to push them together, and potential energy increases. Question 12. A transverse wave does not have A. A compression. B. An amplitude. C. A frequency. D. A wavelength. Answer. A. Explanation. Transverse waves do not have areas of compression and expansion as they move perpendicular to the direction of the wave. Question 13. How do a scalar quantity and a vector quantity differ? A. A scalar quantity has both magnitude and direction, and a vector does not. B. A scalar quantity has direction only, and a vector has only magnitude. C. A vector has both magnitude and direction, and a scalar quantity has only magnitude. D. A vector simply has direction, but a scalar quantity has magnitude. Answer. C. Explanation. A vector quantity, for example, 25k/hn, has both magnitude and direction. A scalar quantity has only magnitude. Question 14. Which one has the highest density? A. Mist. B. Water. C. Steam. D. Ice. Answer. B. Explanation. Ice, choice D, floats on water, choice B, because its density is less, despite the fact that it is a solid. When water freezes, its volume increases, making its density, mass/volume, less. Question 15. There is a 12-unit gravitational force between two items drawing them together. When the distance between two items is doubled, what is the resultant force of attraction between the two? A. 3 units. B. 6 units. C. 24 units. D. 48 units. Answer. A. Explanation. Increasing distance by a factor of 2 decreases the force by a factor of 2 square, or 4. The new force of attraction is the original force divided by 4, or 3 units. Question 16. What is the function of a switch in a circuit? A. To change the flow of alternating current. B. To raise the batteries or cells voltage. C. To increase the resistance of wires in the circuit. D. To allow the circuit to open and close. Answer. D. Explanation. The switch interrupts the electrical circuit or allows the current to flow from one conductor to another. Question 17. When an automobile is driven for a long period, the pressure of air in the tires rises. This is best described by which of the following gas laws? A. Boyle's law. B. Charles's law. C. Gay-Lussac's law. D. Dalton's law. Answer. C. Explanation. Gay-Lussac's law states that temperature and pressure are directly proportional. Heat from friction caused as tires rub on the road increases the temperature of the air in the tire, causing an increase in pressure. This is why it is recommended that you check the pressure in your tires when they are cold, before beginning a trip. Question 18. A 5 cm candle is placed 20 cm away from a concave mirror with a focal length of 15 cm. About what is the image height of the candle in the mirror? A. 30.5 cm. B. 15.625 cm. C. -15 cm. D. -30.5 cm. Answer. C. Explanation. You are looking first at the relationship between the object distance, the image distance, and the focal length, f. Question 19. A plucked guitar string makes 80 vibrations in 1 second. What is the period? A. 0.0125 s. B. 0.025 s. C. 0.125 s. D. 0.25 s. Answer. A. Explanation: the period is the reciprocal of the frequency. Here, the frequency is 80 vibrations per second. The period is 1/80th, or 0.0125 s. Question 20. A 2,000 kilograms car travels at 15 meters per second. For a 1,500 kilograms car traveling at 15 meters per second to generate the same momentum, which would need to happen? A. It would need to accelerate to 20 meters per second. B. It would need to add 500 kilograms in mass. C. Both A and B. D. Either A or B. Answer. D. Explanation: momentum is the product of velocity and mass. The first car's momentum is 2,000 times 15 equals 30,000 kgm/s. The second car's momentum is 1,500 times 15 equals 22,500 kgm/s. To equal the momentum of the first automobile, it may either speed to 20 kilograms per second or increase its mass by 500 kilograms. Question 21. Which of the four wires described above would you anticipate to have the highest resistance? A. 1 km of American wire gauge 1, diameter 7.35 mm. B. 1 km of American wire gauge 2, diameter 6.54 mm. C. 1 km of American wire gauge 3, diameter 5.83 mm. D. 1 km of American wire gauge 4, diameter 5.19 mm. Answer. D. Explanation: the resistance of a wire depends on length, material, and cross-sectional area. Given four wires of the same length and material, the thinnest wire would have the highest resistance. Question 22. A 5 kg block is suspended from a spring, causing the spring to stretch 10 cm from equilibrium. What is the spring constant for this spring? A. 4.9 newtons per centimeter. B. 9.8 newtons per centimeter. C. 49 newtons per centimeter. D. 50 newtons per centimeter. Answer. A. Explanation: the equation to use is K equals F/x, where K is the spring constant, F is force, and x is distance. First, find the force in newtons. Since the gravitational constant on Earth is 9.8, multiply the mass, 5, by that constant to find the force. 9.8 times 5 is equal to 49 N. Now calculate the spring constant. K equals 49 N/10 cm. K equals 4.9 newtons per centimeter. Question 23. A 1,000 kg car drives at 10 meters per second around a circle with a radius of 50 m. What is the centripetal acceleration of the car? A. 2 meter per second square. B. 4 meter per second square. C. 5 meter per second square. D. 10 meter per second square. Answer. A. Explanation: determine the acceleration by dividing the speed squared by the radius of the track, A equals v square upon r. In this case, A equals 100 upon 50, or 2 meter per second square. Question 24. A 3-volt flashlight uses a bulb with 60 ohm resistance. What current flows through the flashlight? A. 0.05 amp. B. 0.5 amp. C. 1.8 amp. D. 18 amp. Answer. A. Explanation. According to Ohm's law, current, I equals voltage, delta V, divided by resistance, R, or I equals delta V slash R. In this case, you know voltage and resistance, so I equals 3/60ths, or 0.05 amp. Question 25. A balloon with a charge of 5 μc is placed 25 centimeters from another balloon with the same charge. What is the magnitude of the resulting repulsive force? A. 0.18 N. B. 1.8 N. C. 10⁻³ N. D. 5 exponent minus 3 N. Answer. B. Explanation. Use Coulomb's law to find the force. The equation to use is this. Thanks for joining us today. If you're hungry for more knowledge, don't forget to explore our collection of nursing exam books available on Amazon. Find the link in the description below. Also, be sure to subscribe to our channel for more educational content. Until next time, happy studying!